Today we're going to use one of the wizards in Mach 3 and we're going to make a program or create a program. I think what we'll do is we'll cut a circular pocket in some MDF. What I'm going to do is show you exactly how to fill the wizard in and hopefully answer some of your questions about speeds and feeds with CNC routers. So first of all, what we're going to do is we're going to bring up the selection of wizards in Mach 3. And there's all sorts of things that we can do: fourth axis, work, angled slot, and there's quite a list of the wizards that you can actually automatically then, by just putting in some measurements and some speeds, the wizard will write the G code for you. So this is a wizard, or this is what a wizard looks like. It's automatically bringing up an end mill. This is an end mill. Okay, it looks identical to what is there. This is a 4-flute end mill. It's a 10mm end mill, which is what we're going to use. The reason why I use an end mill, if you notice there, I don't know if I can get it in focus there. If you notice there's 4 cutting edges right on the very face there. So when the tool plunges into the material, it'll actually cut it away as well. Similar to a drill, this has a flat cutting surface, or cutting edges rather. And with something like, let me see, now this is rather a long extended rotor cutter. Okay, now these are really primarily for cutting sideways, because these are the cutting surfaces here. There's 2 of them. And on the end, you notice there's only a very, very small cutting surface there, and there's nothing in the middle. So what happens is, when you plunge a cutter like this into material, it cuts away both sides there, but it doesn't cut what's underneath the cutter there, and it just tends to burn the material away rather than cut it. So that's why I use an end mill to do a cut down in, like so. That doesn't mean to say that you can't use this cutter to do a cut down in, but what I do, and I'll show you if I've got time to get it on this video, in ArtCam, not Mach 3, but within ArtCam, when I write a program in that, I can elect to do like a zigzag down into the material. So in that case, you can use this tool because it's cutting sideways as well as going down in, and it cuts the material away before this non-cutting area gets anywhere near fresh material. Okay, so just brought you in a little closer so you can see what I'm doing. Now then, in the case of what we are going to do, alright, we are going to leave the 0 point, or the beginning of the program, right, as x0, y0. So what I'm going to do is I'm going to bring the router over top of the material to the position, the central point where I want this pocket to be cut, and I'm going to set the 0 position as the central position of the pocket. If I put a figure into these, if we said, for example, this is going to be a 50mm diameter pocket, I could put in here minus 25, and it would bring me over to this corner here, and that would be the 0 position or start point. I've got an aircraft going over top now. Okay, so we've established that we're going to have the start point of this program in the center. So we leave that as 0, 0. So that's x0, y0. Okay, pocket diameter. Now what you do is you highlight the little region there where it says pocket diameter, and so it's grayed, and then you can fill in what you want it to be, or the dimensions that you wish to use. In our case, it's going to be 50.0 millimeters. Now you have to press, every time you make an adjustment here, you have to press enter, otherwise it won't register it. So then now that is locked in. The step over in percentage of the tool. So that means, say for example, we're starting here in the middle. Every time it does one complete circuit, the step over, in other words, the amount of percentage of the diameter of the tool. Okay, if you said 50%, you want step over, that means it's going to step over 5 millimeters. It's probably okay. We're only cutting MDF, but what I will do is I will set the program up as though we are cutting pine. Okay, so I would say here, and this is trial and error, you will get this sort of with experience, but this is trying to give you a bit of a guide here. So I'm going to say 33% or 1/3. Roughly speaking, and press enter. Now that's locked in. Feed rate, now this is millimeters per minute. Now if you start using ArtCam uses millimeters per second. So you've really got to watch what you are doing when you are setting these programs up, because if you get them mixed up, you can end up with very rapid movements, or alternatively very slow movements. Okay, so what we're going to say here is a feed rate. Do a feed rate of 500 millimeters per minute. Because we've only got a 50 millimeter diameter pocket, you know, we don't want the thing to move that quickly. So I consider 50 millimeters per minute. That's probably going to be a little bit on the slow side, but I'm doing it for a reason, and that will become evident to you when we're running the machine. Because what I'm going to do is I can alter that figure within Mach 3 up to 300%. So in other words, I can alter that figure as we're cutting up to 1500 millimeters per minute, which would be fairly damn quick as well. So okay, so we'll lock that in. Rapid height movements, 10 millimeters over the material is fine. Enter. Feed plunge rate 300 there. Press enter. So it's 300 millimeters per minute of Z down. But there again, I can alter that on the run by 300%. So we can actually make that 900 millimeters a minute. This is all going to be fairly slow. I mean, it's not going to be very rapid, but I'm just doing it for demonstration purposes. Depth of cut. Total depth of cut, that is. That's in actually how deep we want the pocket. So we're going to go 5 millimeters. 5 millimeters, press enter. There we go. Now, can you see over this side? Yes, you can, just about. Now then, step depth. Now what step depth is we're going to start off in the center here, and we're going to plunge down in not 5 millimeters, not the full depth. We're going to go half that, so we're going to go 2.5. So that's what the step depth is, 2.5 millimeters, and press enter. So to machine this pocket out a total of 5 millimeters, it's going to machine this pocket twice. Each time it's going to machine it 2.5 millimeters. Okay, now this is to do with, this is climbing, milling, or conventional milling. I like to climb because I find it works better for me, which means actually clockwise or counterclockwise. So in other words, as the spiral goes on here, this is counterclockwise, which is standard milling. And while I'm machining MDF, I find it better if you go clockwise. So you bite into the material and you can evacuate it quite quickly. Now then, tool diameter, 10 millimeter. So we put 10 millimeters in there and press enter. Mustn't forget to press enter every time. I hope I've done it every time. I think I have, yes. Oh, incidentally, ramp moves. Now it will ramp in from one area to another. It'll only do one ramp move. So that's right at the very beginning. That's okay. I'll leave it as standard. Feed rate, so that's done. Tool number really doesn't matter. We'll put tool number 1, just for good practice and name. Anyway, so we have now filled in everything that we need to fill in here, and we are now going to post the code. What that means is you're telling Mach 3 that, okay, you filled everything in and you want Mach 3 to write that code with these the geometry of this that you've just put in. So just press that and it posts the code. It's made the code. Exit, and it will automatically go into Mach 3. There it is there. Okay, to start off with, the spindle, or the actual router motor itself, is now at the home position of the machine. And what I've done is I've put a very pointy tool in here. So what we're going to do is we're going to take the router over to the work position over there where I've marked, and we're going to zero the X and Y position. So what you do, you get it somewhere pretty close, just by the arrows on the keyboard, and you get it within, well, very close. That's the wrong way. So actually what I'm after at the moment is just the X and the Y. I've just got my X and Y position. Let's take it out of there. So what I just took it out of then, that's the distance between the machine home position and the workpiece. So we'll take it out of that at the moment. And so what we're going to do now is I've just sent. What I've just done is I've just brought the that pointy tool to the zero position of the work that I've marked. So what I do now, I reset this to 0, the X and Y anyway. So X 0, Y 0, and what you need to do then in Mach 3 is regen the toolpath, like that, and then that repositions the actual the workpiece in relation to the actual table size. So now we're going to put the 10mm end mill in, or slot drill, and we are going to zero the Z position. Now, some of you may have seen me do this trick before, so what we're going to do, we're going to bring this the Z down now, and the tool down till it touches this piece of paper. This piece of paper is about 1/1000 of an inch. So within 1/1000th of an inch is fine for working on wood. So what I'm going to do is just move it back and forth like this when the tool gets close to it, and when it grips it, I know that it's pretty well there, and I can set the 0. There you go, just grip it now. See, it's just grabbing it. So I know that's within 1/1000th of an inch of the surface of the material. So I can now set the 0 of the Z, which is as simple as that. And then Regen the Toolpath. So now I know that Mach 3 knows exactly where the center, or where I want to start that piece of work, right bang in the center of that 50mm pocket that we're going to cut right now. Right, so now what I'm going to do is I'm going to start the VFT up. Which is set for approximately 10,000 RPM. So what I'm going to do now is I am going to set the feed rate within Mach 3 at 50% of what the actual value was that we set in the program that we just wrote. So we come over to here now and we say cycle start. And you can see that it's going relatively slow. So what I'm going to do now is I am going to speed the rate up by using this. I'll start 100%. Okay, so actually we can go quite a bit faster than that, because we can go to 300%, and this is what that looks like. So this is running at 300%. This is 1500 millimeters per minute, which is about the correct speed. And that's the end of the program. Okay, there's our 50mm pocket. That is exactly 5mm deep. It's a very clean cut here. It's just a little ragged on the top, which cleans off very easily actually. You can do it with your finger. So that's a very simple demonstration how to use a wizard in Mach 3, or one of the wizards. That was a very simple demonstration. If you wish to see much more complex use of G-codes and CAD systems, if you go to my YouTube channel and if you press on video number 91, I actually demonstrate how I take a picture straight off the internet, up into a 3-dimensional relief. Write the G-codes, and in 93 I actually cut that piece of work. It's actually an eagle just coming to land, I suppose going after a piece of prey, but it's very dramatic. I've had a lot of people contact me via email and in the comment section. Where do I get G-codes from? Well, what I'm trying to do is show you exactly how to start with G-codes by using the wizards within Mach 3 and also ArtCam, because I know a lot of you guys out there actually write these codes yourself. I personally can't do it. I don't have the time or the inclination to do it really. So I use the Mach 3 wizards, but I also use I use ArtCam, which can do very, very complex jobs and G-codes, but it can also do very easy jobs, such as this. I hope this video you have found interesting. I do plan on doing a few more like this, to start off with the easy stuff and then work up to the more complex stuff. So if you have, please subscribe to my channel, press like, and press on the little red box down there. That will take you to my YouTube channel, where there's now 100 or so videos that you can have a look at, ranging from G-codes to operating the CNC and the different jobs that I cut on the CNC, to wood turning and other shop projects that I do around here. So it's been nice having you, and bye for now.